Hey, what's up, guys? Welcome back. And today, let's learn BGP route selection. So, we're going to configure route selection by changing the various BGP attributes. Let's look at the plan. So, BGP route selection. So, the introduction here, we have got the objectives. So, upon completion of this task, you will be able to 1. Change the AS path attributes to affect route selection. 2. Change the local preference attribute to affect route selection. Change the MED attribute to affect route selection, that is the cost. And change the preference value attribute to affect route selection. So those are the two steps that we are going to implement. The networking topology is as follows. Then the preceding figure shows the device interconnection mode and IP addresses of interconnection interfaces. Loopback 0 is created on each device and its IP address in the format of 10.0.x.x/32, where x indicates the device number. For instance, router 1 will be 10.0.1.1, router 3 will be 10.0.3.3. All devices use the IP address of Loopback as their BGP router IDs. Router 1 reside in AS100, router 5 reside in AS200, router 2, router 3, and router 4 reside in AS64512. OSPF runs in AS64512, and OSPF is activated on the interconnection interfaces, excluding the interfaces connected to external AS, that is AS100 and AS200, and Loopback 0 interfaces. So exterior border gateway peer relationship are established through directly connected interfaces, and IBGP peer relationship are established through Loopback 0 interfaces. So meaning that EGP is going to be established by the physical interfaces, while the IBGP is going to be implemented by the loopback interfaces. Router 1 and router 5 share the following network segments: 172.16.1.0/24 to 172.16.4.0/24. Router 1 and router 5 are configured to advertise routes are destined for a network segment to their BGP routing table for route selection. So the background here, you are a network administrator of a company. The company's network uses BGP to access two service providers, that is ISP1 and ISP2. The company uses private AS number 64512. The S number of ISP1 is 100 and that of ISP2 is 200. The same network can be reached through AS100 and AS200. You can adjust a route direction by changing the various BGP attributes. So that's where we are told here by the end of this session, you should be able to configure these four BGP attributes. So that is the practical, that is the task we're going to implement. So let's start our devices. So let's jump straight away and configure the interfaces by giving them IP addresses. So we start with our router 1. So router 1, we undo terminal monitor. Then we give it the name. So this will be router 1. On router 1, we have got one interface, that is gig 2. So interface gig 0/0/2. IP address will be 10.0.12.1/24. Then we were also told to that loopback addresses are given according to the device number. So interface loopback 0, the IP address here will be 10.0.1.1/32 because it is router 1. Now that you are done with that, go to router 2, UTM, change the device name. So this is router 2. It has two interfaces, that is gig 3 and gig 2. So interface gig 0/0/3 that connect to router 1, give it IP address of 10.0.12.2/24. Then gig 2 that connects to router 3. Gig 2 will give it IP address of 10.0.23.2/24. You quit and you create the loopback interface. So interface loopback 0, IP address is going to be 10.0.23.3 10.0 no sorry it's a loopback 10.0.2.2 because this is our router 2 and is a /32. Then we go to router 3 and do terminal, change the device name. So this is router 3. So here it goes two interfaces. So interface gig 3 and gig 2. Interface gig 0/0/3 that connect to router 2. IP address will be 10.0.23.3/24. Then gig 2 IP address here is 10.0.34.3.34.3/24. You quit and create the loopback interface. So interface loopback 0, IP address sorry not channel, this should be quit. Interface loopback 0, IP address of 10.0.3.3/32. Then you go to switch 4, router 4, not switch, router 4. UTM, change the device name. This is router 4. Interface gig 3, gig 0/0/3. IP address here is 10.0.34.4/24. And gig 2 IP address here is 10.0.45.4/24. You quit and enter the loopback interface. So interface loopback 0, IP address here is 10.0.4.4/32. Then finally we are on router 5. So we give it the name of router 5. Then interface gig 0/0/3. IP address here is 10.0.45.5/24. and you quit and create the loopback interface. So interface loopback 0. IP address here is going to be 10.0.5.5/32. After we are done, we save. So after you create the interfaces addresses, you also go back to router 1 and router 5. We create multiple loopback interfaces on router 1 so that router 1 can advertise the loopback routes to the BGP routing table. So the loopback routes that are going to be advertised are loopback 1, that is 172.16.1.0/24, all the way to 172.16.4.0/24, that is loopback 4. So those are the routes we are going to advertise in the BGP. So enter our router 1 here. So we are going to enter interface loopback 1. IP address here is 172.16.1.1/32 because it is router 1. So and loopback 2 IP address will be 172.2.1/32. Loopback 3 is 172.3/32, and loopback 4 IP address is 172.4/32. You do the same to router 5. On loopback 5 interface loopback 1, IP address here is 10. IP address is 172.16.1.5. This is router number 5/24. And loopback 2 will be 172.16.2.5. Loopback 3 will be 172.16.3.5, and loopback 4 will be 172.4.5. Let's go and check something on router 1 here. Router 1, we made a mistake of configuring /32, but it should be /24. Interface loopback 1. Give it /24. Loopback 2. /24, loopback 3. /24, and loopback 4 finally. For /24. So after that, we are going to test connectivity from router 2 and router 3. So quit and you ping router 1 interface. So 10.0.12.1 is able to reach, and also the interface that connect to router 3. So 10.23.3 is able to reach. Also on router 4, we are going to test our router 5. So ping 10.0.45.5, the packets are able to go through. So after that, the next thing we're going to do now is going to configure OSPF on our company, that is on AS64512. We are going to use a loopback address as our router ID, and also we're going to enable OSPF on the interconnection interface, though that is the gigabit interfaces and also the loopback interfaces. We are told that to exclude advertising the LSS on the interface that connect to the external AS, that is AS100 and AS200. So interface gig 3 here, we are not going to enable OSPF on that interface, and interface gig 2 that connect to AS200. We are only going to enable OSPF on gig 2 and also the loopback. So we can now OSPF here, OSPF with a process ID of one area, router ID here, with OSPF1, I use a router ID of 10.0.2.2 because this is router 2. Area is area 0. The network that we are going to advertise is for the loopback, that is network of, so advertise the network of 10.0.2.2. that is for the loopback. Our wildcard mask will be 0.0.0, that is 32 based. Then next we advertise the network for gigabit 2. So network of 10.0.23.1.2, wildcard mask of 0.0.0.0. You also go on router 2, you advertise. So OSPF 1, the router ID here will be 10.0.3.3. Area, we are on area 0, and the network for the loopback, so network of loopback 0. Network of loopback 0 is 10.0.3.3, wildcard mask of 0.0.0.0. Then address the network for that gig 3, so network of 10.0.23.3, wildcard mask of 0.0.0.0. Also, we advertise the network for gigabit 2 that connect to router 4. So network of 10.0.34.3/0.0.0. You come to our router 4 and configure the OSPF. You quit. Enable terminal so that you will be able to see the LSS. Now OSPF here is process ID of 1. OSPF process ID of 1, router ID here will be 10.0.4.4. Area is 0, and the network for the loopback will be 10.0.4.4, wildcard mask of 0.0.0.0, and we advertise the network that connects to router 3, so network of 10.0.3 34.34.4 particular mask of 0.00. We were told not to advertise the interface that connect to the external AS. So after that, we are done with the OSPF. The next thing now is to display the routing. So on this, let's display OSPF routing. You can see the routes here. I got the stub, transit, stub, and transit. So all of those are just intra area. They are just within the same autonomous system. We have got a 0 inter area and 0 external area. So the next thing now is configuring the BGP to establish BGP peer relationships. First, we configure IBGP peer relationship through loopback interfaces and eBGP through the physical interfaces. So while on router 1 is on ISP1 with the AS number 100. So we quit AS number here, BGP 100. On BGP 100, we were told to use the router ID as the for the loopback. So router ID is 10.0.1.1, and we advertise the peer is peer will be 10.0.12.2. The S number here is 64512. So because that one we were told that when establishing eBGP, it's going to establish an eBGP peer with router 2. Now there's no need to connect it to the loopback interface. Then we go to router 2. Quit and quit again. It's on eBGP. So BGP here is 64512. We're going to establish IBGP peer with router 3 and eBGP peer with router 1. So router ID here is 10.0.2.2, and the peer, the first peer will be, that is going to be IBGP peer. So peer will be 10.0.3.3 because we were told to create an IBGP with the loopback interfaces. So AS number here will be, AS number is 64512. And now we are going to tell it to connect to the loopback interface because it is not a physical interface. So peer 10.0, sorry, this was router 3.3, that is our router 3. Then tell it to connect to the loopback, connect interface loopback, interface loopback 0. Then we create a peer for the IBGP peer. So eBGP peer will be now, that is AS100. So peer 10.0.12.1. AS number here, AS number here is 100. Then as OSPF is not activated on the interconnection on this physical interface here, OSPF was not activated on gig 3, router 2 needs to be configured to change the next hop address to the IP address of the source interface when advertising them to IBGP of router, IBGP peer router 3. So we are going to enable a next hop on address on router 2 here. So will be now peer when we advertise to router 3, so peer 0.3.3, and we tell it the next hop local. Let's check on this our router here. Okay, everything is okay. The next thing now, we go to router 2, router 5. Wait. Router 3, on router 3 here, it's going to create an IBGP peer with the router 2 and router 4. So interface you quit. So on router 3, it's going to create an IBGP peer with the two routers, router 2 and router 4. So BGP here is, we are on BGP 64512. That is the internal BGP. Now we create a peer with router 2, interface of router 2. The interface, first of all, let's undo terminal. TM. So peer loopback 010.0.2.2. The S number here. It's BGP 64512. Peer 10.0.2.2. The S number here 64512. Then we are going to tell it to connect to the loopback interface. So peer 10.0.0 connect interface loopback 0. After that, we create a peer with router 4. So peer router 4. Router 4 is on loopback 10.0.0.4.4. The S number is, they are on the same AS now. Tell it to connect to the loopback interface. So peer 10.0.4.4 connect to loopback interface loopback 0. After that, we are done with that router. We go to router 4. On router 4 is also on BGP 564.512. Peer is going to establish an IBGP peer with router 3. So IBGP peer loopback 0 is 10.0.3.3. The S number is 64512, and I establish you connect to the loopback. So peer 10.0.3.3 connect to loopback interface 0. Then we establish an eBGP exterior border gateway with a router on AS200. So peer 10. This one now we are going to use the physical interface 10.0.45.5. AS number is on AS number 200. Then we go to our router 5 here. BGP is 200. peer is going to establish a peer with the router number 4. So peer 10.0.45.4 AS number is 64512. So after we are done, we are going to check the peer relationship status on router 2 and router 4. So we enter BGP, we enter into router, either router 2 or router 4, display BGP peer. Display BGP peer. When display BGP peer, you can see the neighbors. It has established a peer with AS100, that is 10.0.12.1, and also on router 4, let's see if I establish an exterior border gateway peer. So display BGP peer. You can see it has established an with an external AS, a peer relation with an external AS, that is 10.0.45.5 on AS200. So now we are going to configure each of router 1 and router 5 to advertise the loopback 1, loopback 2, loopback 3, and loopback 4 routes to the BGP routing table. So we enter router 1. Quit. Router 1, we are on BGP. Router 1, we are on BGP. BGP here is 100, so BGP 100. We are going to test those networks. So network of 172.16.1.0/24. The next network is 172.2/24, and the third network will be .3/24. Then the fourth will be /4, 172.16.4.0/24. Then we go to router 5. We also advertise those loopback addresses to the BGP. We are still on BGP 200, so network here will be at 172.16.1.0/24. The second network will be, network will be 172.16.2.0/24. Then the third network will be .3/24. Then our last network to be advertised will be 172.16.4.0/24. Then check the routing table on router 3 to check whether router 3 has learned the BGP route successfully. So we are going to check on this, our router 3 here. I want to display BGP routing table. So display BGP routing table. When you display BGP routing table, you can see this loopback networks have been advertised. That is 172.16.0.1 and 172.16.2.0/24, so on, and also 172.16.4.0/24. The next hop has been given here. For 172 has two next hops. So the first next hop is 10.0.1 0.0.2.2, that is on router 2, and another next hop is 10.0.45.5, that is on router 5, that is on router 5. So once we've confirmed that those routes have been advertised into our BGP, now we are going to implement the route selection by changing the AS path attribute. So on router 1, we are going to configure a route policy to change AS path attribute of the BGP route 172.16.1.0/24, so that router 3 preferentially select BGP route to 172.16.1.0/24 advertised by router 5. So enter our router 1. So router 1, we are going to advertise IP. We are going to create a prefix IP prefix. Here we are going to use the list number 1. So we are going to specify the list name. So the list, we are going to use list number 1, and we are going to tell it to permit the network of 172.16.1.0/24 greater than equal to 24, less than equal to 24, that is the mask. After that, we create a route policy number and we name it HCIP. So route policy HCIP. Then after, we give it node number. Node number here will be node number 10. Permit node number 10. Then we tell it to apply the IP prefix list number 1 to modify the AS path attribute to match the route. So if match IP prefix 1, tell it to apply the AS path of 300, 400 additive. Then after that, after creating that node 10, we are going to create an empty node in the route policy to ensure that no other operation is performed on the other 3 BGP routes. So because we were having 4 BGP routes, that is loopback 2, 3, and 4, those are required not to change. So we are going to create an empty node so that they are not affected. So we create an empty node. So empty node here will be node number 20. So will be route policy HCIP permit node number 20. Then we just leave it empty like that. We quit and we go to, we apply, we're still on that router. We apply the route policy to the BGP to be advertised to the BGP peer router number 2. So BGP 100 peer here is going to be 10.0.12.2 route policy HCIP. We tell it to export. After that, what we do is to trigger an export soft reset on router 1 to update the advertised routes. So refresh BGP all export. Let's now check the detailed information of the BGP route to 172.16.1.0. So display BGP routing table network of 172.16.1.0 1.0/24. You can see these are the full information of that route. This is a BGP on local. Route ID is that. AS number is this one. Available paths are 2, but the best path is 1, and that best path has been selected. That is from router 10.0.0.2.2. That is router number 2. Our next hop is 10.0.23.2. Then the outbound interface is gigabit 3. Original next hop is 10.0. Original next hop is 10.0.2.2, and it is from router number 4, that is 10.0.4.4. So the second attribute that we are going to change now is going to be the local preference attribute. So on router 4, we are going to configure a route policy to change the local preference attribute of BGP route to 172.16.2.0/24, so that router 3 will preferentially select BGP route to 172.16.2.0 advertised by router number 4. So we go to router number 4, we create the IP prefix. IP prefix here is going to be HCIP. Create a prefix number 1. On router 4, we are going to create an IP prefix list number 1 to match the BGP route to 172.16.2.0. So IP on our router number 4, we are going to now, we are going to change the local preference value. So we are going to create first of all the IP prefix. So IP prefix IP prefix number 1. We are going to address the net. We are going to permit a network of 172.16.2.0/24 greater than or equal to 24, less than or equal to 24. So it has been created. After that, we are going to apply the route policy. So let's look. It is telling us that the filter is already exists. So let's display route policy. Route policy here. Route policy here is going to be route policy HCIP. HCIP. Now we are going to tell it to permit node number 10. The route policy HCIP to permit node number 10 if it matches IP prefix number 1. We are going to apply the local preference value of 200. Then I quit, and after that we apply the route policy. Before we quit, we are going also to create an empty node so that other routes are not affected. So empty is node number 20. Quit. Then we apply the route policy to the BGP routes. So BGP 64512 here is going to be 10.0.3.3. so that is advertised on router number 3. Route policy HCIP, tell it to export, then you quit, and we're going to trigger an export soft reset on router number 3, on router number 4 here. So Control Z, so refresh BGP all export. Then we come to switch D, router number 3 here, display BGP routing table 172.16.2.0/24. When you see here, the route advertised by router number 2 is local preference value is 100, and the route advertised by router number 4, this one is the route advertised by router number 2. The local preference value has been set to 100. Then when we check the route advertised by router number 4 here, the local preference value is 200. So router 3 will preferentially select a route advertised by router number 4, that is the higher preference value of 200. Then after that, we are going now to configure another attribute, that is changing the MED attribute, that is the cost value. So we are going to our router number 2 here. On router number 2, we configure IP prefix of 1. IP prefix of 1. We are going to tell it prefix of 1 to permit the network of 172.168.3.0/24. Then greater, tell it to be greater or equal to 24, less or equal to 24. After that, they tell it to exist. Now we are going to create now the route policy. So route policy HCIP to permit 17 node number 10. So on node number 10, if it matches IP prefix, 1, we're going to apply cost of 200. Then we create an empty node. So that other routes are not affected during the operation. So wait and create an empty node. So route policy HCIP permit node number 20, and we leave it empty. Quit. After that, we are going now to trigger a route refresh. Now refresh. Before we refresh route, we are going to apply the policy to the BGP routes received from the BGP peer route number 1, peer of router 1. So we are going to be on BGP. So BGP 64512. Peer is going to be 10.0.12.1 route policy here. So we are going to apply the route policy to the BGP peer routes received from the BGP peer router number 1. So route policy here is HCIP. We tell it now to import HCIP to import the route. Now we are going to now tell it to refresh when importing the route. So refresh BGP all when importing that route. Then we are going to, on router number 3, we are going to configure router number 3 to compare the MED values of the BGP routes received from peer in different AS. So BGP here is 64512. We tell it to compare a different AS MED now. Wait, and now display BGP routing table, detailed information for 172.168.3.0/24. When we do that, we're going to see the MED value for the routes advertised by router number 2. Router number 2 had a loopback of 10.0.2.2. So we see the MED value has been showed here to 200, has been changed to 200. Then the MED value for the route advertised by router number 4 here is now 0. So router 3 here will preferentially select the route advertised by router number 4, which has a lower cost, that is the MED value of 0, to be the route selected. So meaning that it will select path to router number 4. So lastly now the next attribute we are going now to configure is now the preference value attribute, so that router number 3 will preferentially select the route to 172.16.4 advertised by router number 4. So enter router number 3. On router number 3, we create an IP prefix. Value here is number 1, and the network that we are going to set the preference value is 16.4.0, subnet of 24, and here greater than or equal to, sorry, there's something I've missed here. We tell it to permit 172.16.4.0 subnet of 24, then greater or equal to 24, less or equal to 20, mask of 24. Then we create the route policy. So the route policy here, route policy, we use HCIP. Then we tell it to permit node number 10, permit node number 10. On node number 10, if it matches IP prefix number 1, we are going to tell it now to apply the preference value of 300, apply preference value of 300. Then after I apply the preference value, we create also an empty node so that other routes are not affected. So route policy HCIP permit node number 20, then we leave it empty. You quit, and after that we are going now to apply the route policy to the BGP routes received from the BGP peer router number 4. So BGP 64512, we are going to apply that to peer of route advertised received from router number 4, that is 10.0.4.4. Route policy here will be HCIP, then import route from router number 4. Then, so on router 3, we are going now to trigger an import soft reset. So refresh BGP all import. Then I will display detailed information about that route. So display BGP routing table 172.16.3.4.0 mask of 24. When you display that, you can see the preference value advertised by router number 2 is 0. Then the preference value advertised by router number 3 is now 300. So we've changed that attribute, but now when selecting the route, the router 3 will select the higher preference value, so that the route advertised by the higher preference value, that is 300. So it will select the route from router number 4, that is 10.0.4.4. So that is how, guys, you can configure the route attributes. That is the practical we were meant to implement now. With that, I think we are done. We've configured the preference value. We have configured the MED. So guys, I believe with that we'll be able now to know how the BGP attributes works and how they influence the route selection when we change the attribute. So thank you for watching the video, and also let's meet in our next chapters of our labs.